How are you guys doing? Well, welcome back. We'll talk here for a few minutes and then let you guys get going on doing stuff. So the plan this week, today is the review day for Chapter 9. And the test then is scheduled for us Wednesday this week. Okay? Yup. That is the next class. Today is the review day. Yes. Yes. Should be one to do good on, since it'll be pretty narrowly focused, right? That usually makes life a little bit easier when there's not a lot of stuff going on. All right. So the as for the test, so on your review packet, if you look at the last page of that, is a list of like formulas or whatever. This is the equation sheet that I'll give you guys for the test. So just FYI, while you're doing the review, that would be what I'd want to have out to look at, just so I get some practice using that and get a good understanding for like what is or is not on there, because there'll be some like basic stuff that I'm going to assume that is common knowledge that maybe didn't make it on there, that you might want to go, oh, fiddlesticks, I forgot what the area of a circle is or something. Yes, Sophia.
So you will give us some.
Is what you get for the test.
Oh, okay.
Okay?
So we get everything.
You get everything that's on that sheet.
Oh,
But what I'm suggesting to you is to make sure that like as you're doing your problems, you're looking at that sheet, and if you run into something like, oh, fiddlesticks, I wish I had that, and it wasn't on the sheet, just so you're like, you know, like SOHCAHTOA might not be on there, and like, God bless you if you don't remember SOHCAHTOA, but like somebody might not remember and go, oh, it'll just be on the equation sheet, don't have to worry about it, and it's like, oh, no, it wasn't. You know, like stuff like that, right? Like nothing big deals, but I want to make sure I was being crystal clear about what you get as far as that goes. Did you guys want to did you guys have any questions from homeworks before we just release you guys to work on stuff?
Yeah.
Sophia?
Can you do 31 and 32?
Sure.
The ID ones.
That's a lie. There were several students that completed both of those problems.
I didn't know.
Not the people that you asked, apparently.
No, not the people I asked. I didn't know. I don't have the slides, and I don't know how to do it.
All right.
I literally wrote, I don't know. I do
Okay, so let's look at 31 then. Okay, so it says the total length of all 12, or it says the dimensions of the container are x, or the length is 2x, the width is x, and the height is y. All measurements are in meters, and the total length of all 12 edges is 48 meters. Cass, you want to flip the light off so it's a little bit easier for us to see? Part A says show that y is equal to 12 minus 3x. So I'm going to use this sentence to come up with that equation. So I know that I have 4 sides that are 2x long, because I have like this one, this one, this one, and this one. Everybody agree with that? And then I have 4 sides that are x long. I have this one, this one, this one, and this one. And then I have 4 sides that are y long, those 4. And that should equal 48. Everybody's okay with that? Okay, so 4 times 2 is 8, plus 4 is 12. I'll just subtract that 12x to the other side. And when I divide both sides by 4, I get the desired result. Right? Everybody's okay with that? Okay. Show that the volume of the container is given by that formula. Well, I know the volume is just length times width times height. So in this case, the length is 2x, the width is x, and the height is y, but if I look at what I've got, there's no y's in there. So what am I going to use instead of y? 12 minus 3x, because I know that's what y is equal to. And if I multiply that out, I'll get the 24x squared minus 6x cubed that's desired. I'm not going to do that for you guys, but you guys hopefully see what to do there, right? Everybody's okay with that? Okay. It says then to find the value of x for which v is maximum. Well, I'm going to use my calculator to do this because basically all I'm doing is I'm going to graph y equals 24x squared minus 6x cubed and find where the highest point on that curve is.
What are you graphing?
The volume formula in part B. The nice part about most of these problems is if you are not able to do one part, you should still be able to do the next part. You might have to use some of the given information from the previous part, but they're usually not like, oh, you couldn't do part B, so C, D, E, F, G, all out. They're usually written in such a way that like you're still going to be able to do that. So it wants to find the x that gives me the biggest volume. So I'm just going to graph the volume equation. So I don't really know how long this is going to go, but I know surely that value of x can't be longer than 48 because the sum of all the side lengths is 48. So I'm just going to use that as my x max. I don't really know how high that volume is going to be, but I know it can't be negative, and I don't know. I'm going to guess that like 500 is maybe a decent upper bound. I'm just taking a guess at it, though. If I have to readjust, I can always come back and readjust. And then I'm going to hit graph and take a look. Okay. So this is the value for my maximum, right? See the highest point on the graph is right here. So I'm going to take a little bit closer look on that just to get a little bit better picture. So that certainly seems like between 0 and 10 ought to cover it. And then up to maybe like 100 should be fine. So there we go. And I'm going to just use my calculator functions to find that maximum. So I'm going to do second, trace, and pick the maximum command. Now it's going to ask me 3 questions. It's going to ask for a left bound. So I'm just going to move my little cursor using the left and right arrow keys so that it's on the left side of that highest point, and then press enter. The question now asks for a right bound, so I'm just going to move my cursor so it's somewhere on the right side of that highest point, and then press enter. And then it asks for a guess. You doesn't matter where you guess as long as it's in between the left and right bounds. So I don't ever even bother to change my position. I just press enter. So there's my maximum, or the x that gives me my maximum volume. So that value for x is like 6 2/3. And that maximum volume looks to be like 56 8/9. Is everybody okay with what we did there? So 5 points. Oops. That's where that goes. And then 56.89 was my volume. It says find the length and height of the container for which the volume is maximum. So I know the length, 2x, so that's 2 times 5.67. And the height is y, which is 12 minus 3x, or 3 times 5.67. Again, I'm going to let you guys run those through your calculator. So far, so good? Sophia, you're okay?
Yeah.
Okay, if I go too fast or I do something you don't like, you know to stop me, right? That goes for all of you guys, right? Speak up if I'm going and I buzz past something you're not sure about. It says the shipping container is to be painted. 1 liter of paint covers an area of 15 square meters. Paint comes in tins containing 4 liters. Calculate the number of tins required to paint the shipping container. Okay, so I need to know the surface area for that container, right? So there's 4 surfaces, or I'm sorry, well, there's really 12 surfaces, but there's 3 different types of rectangles, right? So I have 4 times length times width, 4 times length times height, and then 4 times width times height. So I'm going to use my answers from part D and F to do that. Well, there's some kind of problem here. Who sees what the problem is? Well, you should say 12 minus 3x is a negative number if x is 5.67, and that certainly seems impossible. So I think I must have typed something incorrectly into my calculator. So that is the volume formula. That's good. Yeah, I definitely wrote down the wrong value. It's definitely not a 5. It must have been like a 2 or something. Yeah, it was a 267, not a 567. Let me just double check that real quick. People make mistakes. At least I didn't make like an operational mistake. I just made a transcription mistake, apparently. So that's 267. That makes a heck of a lot more sense. Okay. I feel better now. Do you guys feel better now? Well, if you don't, I'm sorry, but that's the best I can do to make you feel better. All right, so I have 4 times 567 times 534. Nope, and when I say 567, I mean 267. Plus 4 times 534 times 399. Plus 4 times 267 times 399. So that gives me about 184.87 squared. If I divide that by 15, that is about 12.32 liters of 1 liter covers 15 square meters. And then if I divide that by 4, that's going to be 3.08 cans. But cans, we're going to have to round up to make sure we have enough paint. I got to round up to 4 cans, right? If I rounded down, I wouldn't have enough paint. So even though common sense would, or like the strict rules of rounding would tell you to round down to 3, the fact that we're in a real world where we have to still have enough paint to cover this thing means we got to round that up, even though it's very close to 3, or much closer to 3 than it is to 4. Cool there, Sulfurs?
Yeah, thank you.
Do we need to do 32? Are you sure?
Can you do it after this?
Yeah, you should do.
Okay. But we're good with this one. That felt not so bad. The first couple of questions were maybe the harder ones, to be honest with you.
Yeah.
Like the show question is usually the signs a waste paper bin made in the shape of an open cylinder with a volume of 8,000 cubic centimeters. What do we mean by an open cylinder? We mean something like trash can, right? Or that it doesn't have a top. Decides to make the radius 5 meters. The area of the base. Well, that's easy. Pi times 5 squared. The height, well, we know the volume is pi r squared times 5 squared times h, so I just have to solve for h there. So that's about 101. And then the total external surface area of the bin. So that's going to be the lateral surface area. That's 2 pi r base. Just one base, though, because remember the top is. So I have 2 times 5 times pi times that 101.86 plus pi times 5 squared. So that's 30 centimeters squared. State whether that design is practical or not. How big is 5 centimeters? It's about 2 inches, right? Now it's got a diameter then, maybe it's this big, but you're talking about like basically like an empty tube that like a map would come in as your waste paper bin. Doesn't seem like it's going to hold many different types of garbages, right? So I would say that's not terribly practical because what kind of garbage is going to fit into something with that small of a diameter? You know, you can't even, I don't know that you'd be able to fit a soda can in there, to be honest with you. So you can make an argument one way or the other about that, you know. Not very stable either. It's also very easy to tip over something that's kind of narrow and really tall, which would also be a problem for a garbage can. So that's kind of the idea there. So far, so good, everybody? Yes, sir.
When you do surface area with no base, so that's neither bases.
Well, I included the bottom.
Just by adding, so but no, that just means no bases at all, right? No top or bottom.
Right.
Okay.
Yeah. Yeah. So I'm not going to write anything down in place of B because we just kind of talked about it, right? Everybody's good with that? But I think the argument that it's a crummy design is it's pretty easy if you just think about it in like a real world setting. Like how big is actually 5 centimeters? Not very. All right. Marin also designs a cylindrical waste paper bin with a volume of 8,000 cubic centimeters. She decides to fix a radius to the base so that the total external surface area of the bin is minimized. Let the radius of the base of Marin's waste paper bin be r and let its height be h. Write down an equation in terms of h and r using the given volume of the bin. Well, that's just the volume of our cylinder where I plugged in 8,000 for V. Not much to do there. It says show that the total external surface area of the bin is given by this equation. So we know that total external surface area is pi r h pi r squared. Now I notice here in this equation that they've given us, there is no h. So I'm going to solve my equation for volume in terms of H and plug that in. Oops, there should be, that's a 2 pi RH, sorry. Right, that's a perimeter. So then if I just slide, this pi cancels out, one of those radius cancel out, and then 2 times 8,000 is 16,000. I still got 1 r in the denominator. And that's exactly what I'm supposed to have, right? Yes, sir.
So what D is asking is going to show the work of how they got it.
Exactly. Show means like do the work on how we can get that formula. Yep. So far, so good? So doing all right? Okay. Part F says find the value of R that minimizes the total external surface area of the waste paper bin. So I'm going to do the same thing I did in the previous problem. I'm just going to type in this equation in D into my calculator and find the minimum value for, or find the R that gives me the minimum value. So let's see, we have pi x squared plus 16,000 over x, and I don't know what a reasonable bound for either of these things is, so I don't know. I'm going to set the maximum surface area to be 1,000 for right now, and take that maximum value of x to be 50, and we'll see what if we have to extend that or not. I'm just guessing here. Must have been way less than both of those things because I didn't even see anything pop up. Let me double check to make sure that I have everything reasonably there. That seems reasonable. Okay. So I'm going to crank that down to like, well, I guess the external surface area for that other thing was almost, it was over 3,000. Maybe that's just not high enough. Okay, let's do this. I'm going to put this at 3,500 because I know that the external surface area of this waste bin has to be at least, or has to be smaller than 30, has to be at most 3278, right? So that's a good upper bound. And then that value for x that we found that at was 2 or something. So this can probably go down to like 10 or 20, but let's do that and then see if that gives me any. There we go. Now I can see it. And it does look like a minimum is reached right around here. So I'll go second, trace, choose that minimum command, and it's going to ask me that same left bound, right bound guess. So that's, I'm currently where my cursor was left of it. So I went ahead and pressed enter and it switched automatically to the right bound. Then I'm just going to scroll to the right until I see it kind of heading back up. So that looks good. I'll press enter there. And then for the guess, I'll just press enter again. It doesn't really matter. So there's my value for the radius, 13.66, and the surface area there is 1,757. Okay, you stupid machine. And then, oh, there's that. And then to get my value of h, I know h is 8,000 over pi r squared. So I can just plug that in then. Oops, let's do it that way. Oops, forgot a 6. Actually, I didn't. I pressed the button. It's so laggy and slow that it didn't pick it up. So that's 13.65. And it says determine whether Marin's design is an improvement upon Nadia's and give a reason. Certainly seems much better design there. You're talking about something that's like, about a foot wide, right? So that's about 6 inches wide, or 6-inch radius there. So you have about a foot wide and about 6 inches tall. That's not a very deep trash can, but it's certainly going to be difficult to tip over, and you're certainly going to be able to fit in like normal sized garbage into it. So I would say it's a better design than the previous one. For those 2 reasons, you can fit more kinds of things in there, like a soda bottle or something. Or a wadded up piece of paper even would be a stretch to fit that in the previous bin. Have to be wadded pretty tightly. And then this one's going to be much harder to tip over because it's basically like a square. You guys buy that? In general, if you're looking for the most efficient shape, like that uses the most or least material and covers the most volume, you want something that's as close to a sphere as possible. So the sphere is your best volume to surface area shape. So the thing that's the closest to a sphere, so like if you're talking about a quadrilateral or a rectangular prism, you want a cube. Something that basically contains a sphere, can contain a sphere exactly. Or in this case, a cylinder that's going to fit like a sphere inside of it. So you guys wouldn't know that, but I'll tell you that. It's something that you'd prove in a calculus course, probably at some point. But there you go. Does that feel good? Were they as bad as you thought initially? Again, like oftentimes the hardest part is just kind of decoding what is it really asking you to get at, and then still being willing to keep on going if you weren't able to do a part of it. Because unlike a lot of other questions, like these IB style questions are not built to where if you can't do part B, you're screwed. Like they're built so that if you can't do part B, you just keep on going, and you should still be able to do potentially the rest of it. And a lot of times on these questions, like the hardest part is not the last part, but it might be some part in the middle or even early in the question. But that's the idea. Yeah, of course. Anybody else? Okay. I feel good work there. Those were good.